Okay, so I'm recording this right now. There's the square. So the square, like, it's really hard to picture it three-dimensionally, but the square is like coming out of the page. So if you want to know the length of the side, it goes from this top curve to the bottom curve. So I'm subtracting those to get the length of the base, which is in here, and then I'm squaring it because it's side squared. And then you go from this x value, -1, up to this x value, which is 2. Does that make sense? And then rectangles of height 1, it's basically the same picture, guys, but like you're given that the height is 1. So the volume is the height times the base, which is 1 times the base, which is top curve minus bottom curve, and then your x values. So that's what you get for that. I don't know if that helped at all. What do you think so far? Are you guys good?
Yeah, I was just confused about like drawing the picture. I can get like the curves, but that's just the pictures kind of threw me off.
Okay, I get that. It's not easy.
That helped.
All right, moving this down. So when you're dealing with a circle, okay, everybody pretty much knows how to graph a circle. It has radius 2, so the base is a circle. Your square cross sections. All right, I want to make note here that, and bear with me, that this top curve here is positive square root of 4 minus x squared. All right, I really need to plug in my mouse. Hold on, I can't use my. Give me a second. Okay, here we go. All right, so this top curve that I'm highlighting, that's positive root 4 minus x squared. This bottom curve, let me pick a different color. This bottom curve here, that curve is negative root 4 minus x squared. So those are top curve minus bottom curve. Does that make sense? Hopefully that's a yes.
Yes.
So a square cross section. All right, let me make a picture. All right, the square, the base goes from top curve to bottom curve. And the square is three-dimensionally, it's coming out of the page, like it's sticking out towards you. So this is the base, okay? This right here is the height. But the base is top curve minus bottom curve. So that's root 4 minus x squared minus negative root 4 minus x squared. And then you're squaring it because it's the side squared. So the volume of square slice is the side squared times the thickness, which is a change in x because you're slicing along the x-axis. All right? And then your x values are -2 to 2. An equilateral triangle, all right, let me, I never used the eraser, so hold on. Oh, look at that. Okay. Okay, equilateral triangle. It's hard. I know it's really hard to picture, but this point is sticking out towards you. So the equilateral triangle base is top curve minus bottom curve, and you can just memorize the formula that this is root 3 over 4 times the base squared. You don't have to do it individually like I did here. All right, so root 3 over 4 times the base squared. The base, I'm going to write over here. So root 3 over 4 times the base squared. The base is top curve minus bottom curve, which ends up being 2 root 4 minus x squared. times dx. Okay, and you put that inside the integral.
You can keep the like root 3 over 4 in the integral, right? Because I know with like the semicircle example, you put like 1/2 pi on the outside. Does it matter?
No, it doesn't matter. You can keep it inside or you can take it outside. It doesn't matter. All right. Any other questions, guys, before I explain the last two? Okay. I'm going to erase this. So now we're looking at a semicircle cross section. So it's like this, the arc is coming out of the page. And the volume of this is 1/2, that's where this is, 1/2 pi times your radius. This is your radius squared. Your radius is top curve minus bottom curve divided by 2, right? Because if you just do top curve minus bottom curve, that's not radius, that's what?
Diameter.
Diameter. So you got to divide it in half. That's why this over 2 is gone over here, okay? And then you just plug this into your calculator. Don't forget to square your radius. And then last but not least, you have a isosceles right triangle. So with and if I don't specify, I want one of the legs in the base. So here's the leg. Here's the point sticking up out towards you. Isosceles, these two sides are the same. This is your right angle. All right, that slice is coming up and out of the screen, okay? And it's 1/2 times the base. The length of the base is, that's a 2, root 4 minus x squared. All right, times the height, which is the same thing, 2 root 4 minus x squared. You know what, I should have written that underneath, because that doesn't look good. Okay, do that again. So 1/2 times the base, which is 2 root 4 minus x squared. And do you agree that the height is the same thing because it's isosceles?
Mm-hmm.
So I'm going to take that and square it. Okay, so 1/2 times the base times the height. The base and the height are the same thing. That's why I'm squaring it. Guys, do you have to simplify the integral before you plug it in? Absolutely not, but I did here. I said this is going to be 4 times 1/2 is 2, and then root 4 minus x squared squared is just 4 minus x squared. You don't have to do that at all. Don't worry about that. Okay. All right, what do you think?
The 2 times root 4 minus x squared is just top curve minus bottom curve, right?
Correct. Yeah, because when you do, let me show you, top curve minus the bottom curve is negative root 4 minus x squared. This becomes 2 root 4 minus x squared. Okay. All right, do you guys have any other questions?
Is that all we need to know to finish the back of the worksheet for homework?
Yeah, let me take a look at the back real fast. You know what? Let me get a blank copy. Okay. I'm not sure. Let's switch this. You know what? I'm going to stop this recording. See if I can figure out how to stop it.